In this lesson, you're going to learn how to simplify algebraic expressions by combining like terms. We're going to apply the distributive property to expressions with variables to identify and simplify parts of expressions. So first, we really have to make sure we're identifying important vocabulary. Terms. So terms are the parts of an expression that are added together with corresponding variables. Terms can be a plus 3 plus z. All of those are terms. A coefficient is the number in a term that is the product of a number and a variable. So that is, for example, in the expression 3a, our coefficient is the number in front of that, so it's 3. In a number like negative x, of course that means negative 1 times x, so your coefficient there would actually be negative 1. Like terms are terms that have the identical variable parts raised to the same power. So for example, like terms would be 3z and 6z. Those are like terms. Constant terms are terms that have no variable. Numbers like 3, 4, 5, all the way up to infinity, 100. Those are constant terms. They don't have an x, y, z, a, b, c after them. So let's review. The distributive property helps us to regroup numbers and variables. For example, we can regroup 5 times 105 as 5 times 100 plus 5 times 5, because we can rewrite this as 5 times the quantity 100 plus 5. Likewise, we can regroup the opposite way. We can add these two and then regroup additionally. We can split up decimals and whole numbers. We can split up parts of fractions or combine things. Whatever you need in order to redistribute the numbers, but you need to make sure you're following the rules. And in this case, you have to apply that 5 to both 100 and times 5. If you need help with the distributive property, then you can go into previous tutorials and revisit the distributive property. Some common mistakes to look out for are confusion with like terms. For example, 7 times the quantity, 3x plus 2. Some kids will add 3x and 2. Well, you can't combine them because they're not like terms. So the example is not 35x. And we'll get into how to redistribute these properly. Another common mistake is multiplying incorrectly. For example, b times b is not the same as 2 times b. Just like when we deal with exponents, b times b is b squared. Just like 7 times 7 is not the same as 2 times 7. Whenever you're confused, I always recommend putting a label behind something. For example, 7 times 3 xylophones plus 2. And you can always relabel the constants, things like apples and oranges. I'll give you additional examples along the way. So let's look at something that we're familiar with, cookies. So let's say we have 4 boxes of cookies. We're adding 7 individual cookies plus 3 individual cookies plus 2 boxes. Now the boxes are unknown quantities. A common mistake is students will think they can combine the individual cookies with the boxes of cookies. Well, it's important that you put the proper label onto things. Because I don't know how many cookies are in each box, I know that it's 4 times the amount of cookies in each box. So we can say 4b. Plus, we have 7 cookies, plus 3 cookies, plus 2 more boxes of cookies. Now, we can combine the like terms, but we cannot combine the terms that are not like terms. So the commutative property says that when I have all addition, then I can change the order. So if I change this to 4 boxes plus 2 boxes plus 3 cookies plus 7 cookies, I can combine the like terms a little bit more easily. Well, again, it's always important to make sure your variable stays correct. So I can combine 2 boxes and 4 boxes of cookies to get 6 boxes. And then I can combine 3 cookies plus 7 cookies to get 10 individual cookies. So my simplest form is 6b plus 10. 6b plus 10 is simplified. A common mistake is students will add 6b and 10, so watch out for that. And it is okay to leave it the way it is. Leave it as 6b plus 10 because we cannot solve for b in this case. Now if I knew how many cookies were in each box, then I could solve the equation. So let's first refresh our vocabulary. Identify the coefficients, like terms, and constant terms of the expression. So looking at this expression, we have 9z minus 4 plus 7 plus z. So my coefficients are the numbers in front of my variables. So I have 9, and if I have just z, that means it's 1z. So I do need to make sure that I put that 1 there. So my coefficients are 9 and 1, and they're both positive. My like terms, well, I have 9z and z. My other like terms are negative 4 and 7. My constant terms are negative 4 and positive 7, because those don't have any variable associated with them. So those are my parts. Now let's look at simplification. Well, when we have up an expression like 3x plus 9 minus x, the commutative property says that I can change the order from 3x minus x plus 9. And I always like to simplify using names for things. So I might call my 9s my cookies, and I might call my x's my boxes. So if I had 3 boxes and I took away 1 box and I added 9 individual cookies, when I simplify, I would have 2 boxes plus the 9 cookies. So that's my simplification. Again, putting a label on things can often make it easier to simplify. Let's look at another expression. We have 6 plus 13t minus 5 minus 3t. Again, I have my like terms in common, and now I'm going to use the commutative property to change the order. So I'm first going to start with my variables. I have 13t minus 3t. Then I have 6 minus 5. And now I can, of course, associate this with boxes and individual cookies. 13 boxes minus 3 boxes would give me 10 boxes, but in this case I'm using t for my variable. 6 minus 5 is positive 1. So my simplest term is 6t plus 1. Let's look at another example. Again, I have my like terms, and I have my constant terms. I'll keep these quarters. So I have 4k minus 2k. Then I have plus 10 minus 7. I can combine my like terms. 4k's minus 2k's are 2k's. 10 minus 7 is 3. So my simplification is 2k plus 3. Again, I cannot combine my boxes and my individual cookies. I can't combine my numbers with coefficients and my constant terms. Now let's take it a step further and apply the distributive property. So I have 5 times the quantity, 1.5 W plus 3. Well, my distributive property says that I can multiply 5 times each of these numbers. So 5 times 1.5 W would be 1.5 times 5. Well, I can even use mental math to multiply 5 times 1, which is 5, and 5 times a half, or 5/100ths, which is 2.5, and 5 plus 2.5 is 7.5. Now I multiply 5 times 3, 15, and then my 2W and my minus 4, or negative 4, stay the same. Now I can, of course, use the commutative property to rewrite combining like terms. So that gives me 7.5 W plus 2W plus 15 minus 4. Now I can combine my W's. 7.5 W's plus 2 more W's is 9.5 W's. And 15 minus 4 is 11. So my simplification, I had to apply the distributive property, is 9 5/10 W plus 11. Make sure you're always double checking your distributive property. Now let's look at another example. Let's simplify Q times 3Q plus 2 minus 7. Now in this case, I'm multiplying Q times 3Q. Now, if I was multiplying a box of cookies times a box of cookies, that would not be adding one more box. That would be adding it that many boxes of a time, which of course Q times Q, we remember, is Q squared. So we have 3Q squared. So that constant actually stays the same. It's the Q that's being multiplied. Likewise, Q times 2, most of you are pretty good at this step. Q times 2 is 2Q. And then, of course, my minus 7 will stay the same. A common mistake is kids will think that they can combine Q squared and 2Q. Order of operations says I need to do my exponents first. So that is why you cannot combine any further. And this is actually in simplest form because I have no like terms at this point. So always remember that x times x is not the same as 2 times x. X times x, of course, is x squared. Q times q is q squared. Z times z is z squared. Always double check whenever you're multiplying a variable times a variable. Now it's your turn. I want you to try simplifying all of these expressions. Remember to write them down in their original form and then simplify as needed. Use the commutative property in order to combine like terms and reorder the numbers as needed. Don't forget to double check whenever you're multiplying a variable times a variable and to use the distributive property correctly. Go ahead and take a minute to pause the tutorial and try these problems on your own. In this lesson, you have learned how to simplify algebraic expressions by combining like terms and using the distributive property. Remember to always use the commutative property in order to change the order of your expressions to help you with simplification, and also remember your rules for multiplying a variable times a variable. Always double check your order of operations and make sure that you always double check that you've combined the right like terms. Another great job today, and remember, simplifying expressions can simplify your life.